Hey, hello, it's me, John Park, and now I've got my audio up. This is MakeCode Live with me, John Park. I suddenly realized, hey, wait, I had taken the mic volume down a second ago. It didn't just go back up on its own. You got to do that part. So welcome. I have a very fun project. I think it's pretty cool and actually really useful that we're going to build today on MakeCode Live. This is going to use the Circuit Playground Express, as you can see right there in the simulator. You can head on over to makecode.adafruit.com/beta if you want to follow along. I think most, if not all, of these features would work in the regular version, but I'm going to use the beta because I like it, especially the code folding or block collapsing that we can do in there, as well as code formatting and a couple other neat interface tricks. And let's see. What else? You know what? Let me double check and see if we're streaming live and healthy over to YouTube and Mixer. I'm going to pop open a Mixer channel. We've got our Discord channel live and healthy, and thank you to C. Grover, who said I can push the volume level up a little bit. That looks pretty good. I'm not always sure if my output in OBS is the same as what it says. It seems to be shy by about 3 dB, 3 decibels. All right, so I'm going to jump to a Mixer view real quick just to see if we're streaming healthily there. Let's pop over. So if you're viewing this on the MakeCode Mixer, it's mixer.com/MakeCode. And I want to keep an eye on the chat there as well. So, all right, good. It looks like we're live and healthy. Okay. Well, thank you for putting up with this setup. Always takes some doing. So let's see. So the project this week, I'm going to talk about the project a little bit. And then I've got a team member video that I'm going to show from Microsoft MakeCode researcher Michal Moskal. And then we'll dive into the project itself and look at how it's built, look at the blocks, maybe do some customization. So the project, I was talking to my son yesterday and I said, what kind of project should I build this week using maybe a Circuit Playground Express and MakeCode? We brainstormed a little bit, and he came up with the idea of creating a volume knob for the computer or any other USB device that takes a volume input over HID USB, and use the Circuit Playground Express accelerometer so that we can just tilt the Circuit Playground Express to change the volume either up or down. In fact, let's have a look at that setup real quick. You can see right here, let me move my camera. I've taken my Circuit Playground Express and I've bolted it to using the little Circuit Playground Express case. This has a camera tripod 1/4 and 20 threaded insert in the back, so you can hook it up to a tripod, and you'll see as I turn this, it's actually adjusting the brightness. So that's my range of motion from 0 to full volume, and as I'm doing that, it's actually changing the volume on my computer. Now I shouldn't be hearing anything right now, so neither will you, I hope, or maybe I blew your ears off, for which I apologize. So that's the idea behind it. And what we're going to do is we're going to look at coding it, and then I'll show you maybe a better demo where you can see and hear things happening on my iPad here, because we can plug that right in as well. So that's going to be our project, a volume knob using Circuit Playground Express with interactive lighting and customization. But as promised, before I jump into that, let's take a look at the MakeCode team member of the week video.
Hello, my name is Michal Moskal and I'm with the Microsoft research side of the MakeCode team. I've been in this project since the very beginning, and I mostly do things like the compiler, which turns the code that you write either in blocks or TypeScript or in Python into the code that runs on the devices, on the hardware devices, or in the web browser. and also on the runtime system, which kind of supports that and so forth. And today I'm going to show you the memory profiling feature of MakeCode. It's a simple program here that does a duck rain, where ducks fall off the sky. So we create a duck every 500 milliseconds. We set it at a random position at the top of the screen and have it fall down at the speed of 100 pixels per second. Now, what you can see about this program is that it keeps creating new sprites, but it never deletes them. And that is going to cause trouble if you run the program on a hardware device. In the browser, you would need to wait like a year for it to run out of memory, but on a hardware device, it will be much faster. So how do you diagnose those problems while you're still in the web browser? Well, that's what the second bit here is about. Every 500 milliseconds, we are going to do a heap snapshot. Okay, so how does that look like? Well, to see those heap snapshots, we need to look at the JavaScript console. And to get to the console, you can like right-click somewhere, for example, on the simulator, and show the and click right-click inspect, and then switch to console. So here we can see the output on the console, and this is the output of that heap snapshot, right? So so you can see every heap snapshot starts with the list of threads of execution, which is maybe not so interesting. Then it lists the summary of the objects that you have. So there is 139 sprite objects at this point, one image object, and so forth. And here on the left, there is the size, there is total size of those objects as they would have on the hardware, if you run that program on the hardware. So we kind of tend to be interested in the biggest one at the bottom. So you see that there is 139 sprites, which probably means that we are creating too much sprites. But sometimes it's not so obvious. So here there is a list of large objects. So the sprites are actually, every sprite is not so large, but there is lots of them, so they take lots of memory. But there are some other large objects that you may be interested in. But really the interesting bit here is where we see new objects. So every 5 seconds, you're going to see the list of new objects created. And here you can see, and that were not destroyed in the meantime. So here you can see actually that there is 10 new sprites created over the 5 seconds. And this is the problem, right? So if you run your game, you usually should see no new objects being created continuously. And here every 5 seconds, we would see 10 new sprite objects being created. So this is a very simple example, so it's actually also very simple to fix. How do we fix it? Well, we need to make sure that the sprite is destroyed when it leaves the screen. And we have a way of doing that. So if I search for flag here, there is this set my sprite to stay in screen. I need to change that to auto destroy and set it to on. And now if I run my program, so it's running again, and we see those screens, those heap snapshots appearing here, and there are no new objects on every frame. And this is how it should look like, right? No new objects. And you see this kind of keeps updating, and there are still no new objects. Now, this is documented under makecode.com/js/profiling if you want more information. Okay, thank you.
sorry about that. Just realized my volume was down. Oh no. So jumping back real quick, thank you to Michal for doing the explanation of tracking down memory issues in arcade games. It's going to be really huge help for people who are doing arcade games on hardware, since they'll play with full memory available on your computer, no problem, but sometimes you'll run out of memory on a device like the Pi Gamer or the Pi Badge. So that's going to be really helpful. And also my apologies to Michal. I had a typo in your name until halfway through, and I fixed that, so shoot. Thank you, Fede, too, over in the Discord channel, and probably people in other chats for pointing out that my volume was off. Okay, so moving on now, let's talk about this volume knob project. So the first question in being able to use a hardware device like the Circuit Playground Express to control the volume on a computer or a mobile device is how do you do that? So the first key to this is adding this extension called Keyboard. So if you look inside of my MakeCode session, you'll see I've got a category here called Keyboard. And the way I got that was by adding the extension. So if you look down here at extensions, you can click there and you can add an extension. I've already got the keyboard extension installed, so you won't see that available in this list since it's already installed, but it's actually related to and similar to this mouse one. So I clicked and added keyboard, and then that will show up in this category section over here on the left. What we can do with the keyboard, if we click on this, I think we've looked at this before and used it for things like typing in a letter or word, but you can also use it for these multimedia functions. So if you look here at keyboard, media, mute, press, I'm going to bring that block in. And you'll see in the drop-downs, we actually have a nice list of what are considered media controls or consumer controls in the HID, which is human interface device, the HID descriptions. And so things like volume, up and down, play and pause, stop, previous track, next track, these are often buttons that you'll find across like a top row on a keyboard, or maybe they share space with the function keys and you can use a modifier to use one or the other. And so that's how often you'll just click a button several times to up the volume or down the volume. And this also then has some web search buttons and a thing that'll bring up your calculator, your mail. So these are some standardized messages that you can send over a USB keyboard to your operating system. So this will control operating system wide volume. It's not for an application, it's just for your operating system. And then we have the option to either press up or down. So it can happen when you press, or just on down or just on up. So I can get rid of that one there because I already have some in use. So now let's take a look at the idea of using this Circuit Playground Express as a rotary knob. So again, if I drop back over to my webcam view, you'll see here, let me reset this. It has a accelerometer in it, and I'm measuring what's considered the z-axis of the accelerometer. And so right now that z-axis is pointed down, and we get a negative value, and then we'll get a positive value up until its maximum. I think this runs roughly from negative 1023 to positive 1023 values or little variations. And as I'm doing this right now, I am changing my output volume, which shouldn't affect us, crossing fingers. But I'm also seeing this visual feedback of the lights brightening so that I know that it's happening. Besides just hearing it, I can see it. So let's take a look at, in MakeCode, how we do those things and how we string together a few different tools and ideas to build this project. So the first thing I'll do is take a look at my on start block, which I have collapsed right now. So let's open that up. And you'll see in here, I can zoom up on this, a few things going on. So I've mentioned this before in these MakeCode Live videos. I like to create some variables for values or numbers that I'm going to be using elsewhere in the program during what I consider to be this setup phase. In this onStart block, this is a loop of code blocks that will run just one time when you restart the device or you restart the program here in the browser. So what happens on start? We're going to create a variable that's called volume steps. I called it vol steps. So volume steps, and I've set this number to 15. So what this is I actually looked in, I'm using a Macintosh computer here, a laptop, and when I press the volume up or the volume down keys, there are actually 16 steps from what I'd consider 0 to 15, or you could think of it as 1 to 16, but for the purposes of the computer program, usually we'll start on 0. So I'm saying there are 15 steps. And I noticed, we went and checked this out on a Windows machine on my son's computer, and he actually had 50 steps when he pressed his. So on the Windows machine, each time you press, it actually adds 2 to the volume slider, and the volume slider goes from essentially 0 to 100. So roughly 100 steps, but it's each time you press the button, it's 2 of them. So we would use a step size of 50 if that were the case, if we're using a PC. And I'll show you a variation on this project where I have accounted for a couple of presets. Now, the interesting thing is if you use some other interfaces on the computer, like there's a touch bar, or you can click and drag a volume slider in the interface, it's a more finely graded or graduated or stepped slider. So you can fine tune things. But if you're just clicking the button, you get essentially 16 steps from mute to 15. So I'm going to use that because I want to keep track of how many times I've pressed the virtual up button, the volume up button, as I rotate my knob. So I need to go between 0, which is mute, and 15, which is full volume. So since I'm going to use that number a couple of different places, I like to have it as a variable right at the start, and then I can use it elsewhere, which we'll see. The next thing I'm doing is setting a state of readiness, and I'm saying at the beginning of this I'm not ready. So how I'll use that we'll see in a second, but it's essentially saying there's a section of the program that I don't want running right away. And so since that section of the program is meant to normally run all the time, just don't start right away, I'm going to use a condition that says if this ready variable is set to false, then don't go, don't do that section. So we'll take a closer look at that in a moment. And the way that you create these variables, by the way, if you're new to MakeCode, is over in this variable category. We have a nice big button at the top that says make a variable, so I can create a new variable. I'll call this test variable. It now joins this drop down that's in a couple of these, and it shows up as an individual variable that you can use elsewhere. So if I bring in, let's say this set the test variable to something or other, and I bring in test variable, those are kind of the two main pieces I'll use. And there's also a change variable, because sometimes you'll be changing what that variable means later on in the program. So that's how I created those. And then to create a value that's not just a number, because by default this has a slot that you can enter in a number in there, or text as well. I'm going to use from the logic category, down at the bottom, there is a true and a false block. And so I grabbed, probably honestly, I grabbed the true block and then switched it to false, just because I often do it that way. But both are available, and they're just variations on the same block. So that's how I created this set ready to false. And like I said, we'll see in a little bit how that's used. The next is, again, there's a number that I'm going to use elsewhere, or not only am I going to use it elsewhere and maybe multiple times, but I want one place to go and tune it when I'm changing the code. So if there's a user editable parameter, if I expect a user to use this code and maybe adjust something to tune it to their liking, I like to put those things right in this on start block. And that makes it clear where you can go and change things. And you can even add comments to these. So it's a good practice. Let me show you this. If I if I want to just leave this program as it is, but give a little note to a user, a potential user, I can right-click on a block and add comment. And now I can add a comment. You can see it even has a little flag tail that points to the block that it pertains to. And here I can say 15 for Mac, 50 for PC. So you can put a short little note like that. If you minimize it, it still shows up that there's something there that'll highlight when you hover over it, and then you click it and pop it back out. If you want to get rid of one of those, you can click the trash can and it goes away. So there's my max brightness, and what this is going to be is how bright do the Neopixels get. So the Neopixels can go from 0 to 255. I think the default is about 20, and 20 is plenty bright. 255, don't look at it. It's retina searing. So I'm setting it fairly bright, and you saw in this webcam view here, it does get pretty bright as I turn this up. You can see that's plenty bright. You can see the reflection on my hand there too. So I'm setting whatever that maximum value is right here to be, could be 20, could be 10 if you're in a darkish room. I set it to 35. That worked pretty well. Then I actually use that variable immediately. And I will use it elsewhere. Otherwise, I wouldn't have gone through all this. But I am going to use it immediately and set, before I've lit up any Neopixels, which are the LEDs that run around the circle around the board, I'm going to use whatever that variable was, MaxBright, and set that to be my maximum brightness. Then I'm immediately going to light up a pixel. So if I run this program right now in the simulator, you'll see now I have a big Circuit Playground Express head. Hello. You'll see that this Neopixel here is lit up. So that lit up on start. And the way I lit that up was it's Neopixel 2. So this is indexed from 0 as the first one, and then it goes counterclockwise to 1, 2, 3, 4, 5, 6, 7, 8, 9. The color here I've set to green, which you can't see right now because I have my green screen on. If I turn off the Circuit Playground, or rather the MakeCode green screen. Oh, no, you know what? You still won't see it because I'm knocking out green screen in OBS. So that green is a pure green, and it's exactly the one I'm knocking out. So you don't see that one when I pick it. We can try to pick a different color here, and you'll see there's the green. It's just always knocked out and showing whatever's behind us. Hello. So the reason I'm lighting that green is that I want the user to press that button to start. So when we start the program, you'll see if I jump back over here again to my webcam view, this button indicates that, well, it's ready. Or it's waiting, rather. It's waiting for me to do something. It's not going yet, so I'm going to click the nearest button, and that'll start the program. So what happens next? Let's have a look at what happens when we click that button. So I'm going to move this forever block out of the way. I'm going to actually minimize or collapse the start block. And let's take a look at what happens on this on-click button. So I'll scroll off to the side there in a second so we can see this big long one and what's going on there. But to start with, I'm going to set all the pixels to a sort of light blue color. So when we're gearing up, it's going to set all the pixels to light blue. And then I'm going to dim those pixels down to 0. And I'm doing this partly so that the user knows that the volume is being set down to 0. And they're going to hear it, or they're going to see the indicator on the computer if it's plugged into something. And they're also going to see these lights dim down. And the reason we're doing this is there is no absolute volume adjustment of your computer, of your iOS or Android device. There is not a USB HID command that sends a percentage of maximum volume. So there's nothing that says tell the volume to be at 50% or tell it to be at 75%. It's always relative. So relative to wherever you've left the volume on your computer, this knob is going to send up and down signals. And you can probably see there's immediately a problem with this because there's no way for the Circuit Playground Express and this MakeCode program to know where I've left the volume. So if this is to go maximum volume when I turn it to the right and sort of straight up and down, and go to the minimum when I turn it upside down, it might be way off. So for example, if this starts out and I've got the knob in the halfway position, but my volume was set to 0 on my computer, as I turn right, it's only going to raise it halfway. So I'll get to 50% instead of 100%. So what I decided to do to solve this is immediately on start, when we hit this button, rather, when we arm the system and say we're ready, as soon as we're ready, what it's going to do is it's going to drop the volume down to 0. And then it's going to set all my Neopixels to essentially the lowest brightness value, 0. This essentially calibrates things or readies my system so that I'm in a known state. Let me move this out of the way. Hold on. I have a way of dealing with wide program. I'll just put it on my forehead. So in order to lower the volume down to 0, what I do is I essentially hit that, I send that volume down command the full step range, which is 15 in this case. So if it was at 5, it doesn't matter. I'm still going to hit this button all the way. And there's no downside to this. You can have your computer sitting at a volume level of 2, and you can press your volume down button 5 times. It'll still just stay at mute. So it doesn't wrap negative or anything like that. It doesn't create a sound vacuum, which would be amazing. So it's a bit of a hack, but what it does is it puts my computer into a known state so that the Circuit Playground Express then will operate based on this relative setting of, I know we're starting at 0. So after I've set the pixels to blue, we're then using this loop to go through essentially 16 times. So from 0 to the number of steps, which I have set to 15. So for each of those steps, we're going to do the following. We're going to press this keyboard media volume down button. So that's one click down on that little ticker. Then we're going to lower the brightness. And the reason this is so sort of lengthy here is I'm setting the brightness on each step. What I do is I remap the current volume steps setting. So initially this is going to be 15 because volume steps is 15 according to my on start block. That's where we start out, 15. And then the index to begin with is 0. Index is a variable that increments 1 each pass through this loop. So it's going to be equal to 0, 1, 2, 3, 4, 5, 6, up to 15. So what we're going to do is remap that number, which starts out as 15, and we're going to take a range that goes from 0 to the number of steps, and we're going to remap that from 0 to 35, which was my max brightness variable that I set back during startup. So this essentially slices up the number of steps to dim between 0 and 35 into 15 or 16 discrete slices to get down to 0. One of the reasons I've set this up this way is that we will be able to change that number of maximum brightness and the number of steps we're using for when we're on the Windows PC. Excuse me. And none of this code will have to change. We can make our changes to the variables at the startup. And then I make a little bit of a pause. It's good with some of this USB stuff to put a little pause between keystrokes sometimes, just in case you flood that USB buffer, you might miss some key presses. So it takes a tiny little pause, 4 milliseconds. So that happens 15 times, so we'll see the brightness drop down. And it happens pretty quickly because 4 milliseconds isn't a lot of time, and these are quick to run. Then what I'm doing is I have a new variable that I'm creating called Keypresses, and I set that value to 0. And I'll show you a second how I'm using that. Excuse me. And Then I finally, I'll tell you what we're using this Keypresses for in a second when we get to the sort of meat of the code, the bulk of it. But a hint is it has something to do with knowing how many steps we have to go to move up or down and match the orientation of the Circuit Playground Express. And then I'm going to set that ready variable to true. And all that does is it allows this to finally happen. So the forever loop, I said there's a big bulk of the code. I'm going to move this down here. So this forever loop, it wants to run all the time. Normally, it'll just do everything that's in that code at every moment of the code running. So the way I stop it from just immediately starting up without getting through my little calibration reset here is everything in the forever loop is actually encapsulated in this if ready. So what that means is if ready is the same thing as saying if the variable ready is equal to true or has a value of true. Remember, we set that to false back here in startup. I can leave this open now, in fact. And I'll move my button over here. How about? Don't want to throw it away. Whoa. So remember, initially the ready state is set to false. It's only after we've pressed the A button that it switches that ready state to true. And now all of this good stuff in here can start running. So that if ready becomes true when we press the A button, go through the calibration. And now we start really sending the program into overdrive, figuring out the rotation or the orientation of the actual device using the built-in accelerometer. It's a tiny little chip that knows which way it's facing. The first thing we'll do is I've got this variable called volume level. And what I'm going to do, this is a lot of code here, but let's break it down. So what I'm using this for is to take whatever the output of the accelerometer's y-axis is and remap those numbers, which I said earlier, they run roughly from negative 1023 to positive 1023. That's the range of the raw output from that chip and its driver. I'm going to take that, and I've actually found just through experimentation that these numbers work a little better for me, is negative 1000 to 890. I'm going to take those numbers and I'm going to remap them to a range of 0, which will be mute at the bottom end, and a number of 15 in this case, which is the number of volume steps. So let's take a look. You can see in action by using this console log value block, I can see what that variable is as I turn the knob. So I'm setting this variable called volume level, and this is a way of essentially turning accelerometer numbers into volume step numbers. So like I said, that would be 0 to 15 on the Mac and 0 to, I guess, 48, right? 0 to 48 on the PC. That one's trickier because it's in increments of 2. So what I'll do is bring back the simulator here, and on my, let's see, you can see all of this at once if I switch views. So on my Circuit Playground Express, I'm going to engage or start. You can see it just ran through that fade and it dropped the volume down to 0 on my computer. It pressed that button, that virtual button, it pressed it 15 times. And now if I open up this show console, so you see this button that appears, this is because my Circuit Playground Express is connected over USB to the computer. I'm using Chrome browser and we have a web USB connection. It's paired. So I'm actually able to feed data right from this real Circuit Playground Express into this browser Windows graph. So when I click on Show Console for the device, you'll now see there is I'm graphing a thing that I named vol, and it has a value of 0. And now as I turn this up, you'll see that number is increasing, and it'll make it all the way up to 16, or rather 15. 0 to 15. And as I'm doing that, you might even see, can you see that? Yeah, I think you're seeing my volume. I think you're seeing that. Yeah, you should be seeing my volume move up and down because it's showing up. Is that true? I can get confused because I'm seeing my real computer. I'm seeing what I'm sending, but I think you're seeing that too. I'm gonna look in the YouTube feed. Yeah, there it is. Yeah, you're seeing that. Good. So that's a nice demonstration of how this is working. So, like I said, the raw values of this are actually negative 1023 to positive 1023, but I'm remapping them so that I just get the number that I need to successfully adjust this volume up and down. Okay, so I'll set that all the way down to 0 and it mutes. If I go back 1 second to close that console, just click go back. And let me go back to the full view here. I'll show you a little bit of extra work that we needed to do in order to make that work well. And that is, you'll notice in this big long line here where I'm setting this variable called volume level, remap, we're familiar with remap. That takes the accelerometer's value from whatever my low and high is and remaps it to this 0 to 15. The problem is the math there works out to be decimal values or fractional values, which I can't use elsewhere. I need a whole number, an integer, to work with this 15 set steps of volume presses that I want to use. So I've added this block. Everything is contained within this block that says truncate. And you'll see there are a few different helpful functions here that we can use to sort of clamp numbers. There's a rounding, there's a ceiling, a floor, and a truncate. So the truncate essentially chops off anything other than the whole number. It turns a float or a decimal into an integer. It says here in the helpful tooltip, removes the fractional part of the argument. So that's how I'm getting a number that's useful. Okay, so console log value, that is only for development. I could get rid of that when I'm done because I don't need it to be thinking about that at all. It's only just while we're developing that I wanted to see those numbers. Now what I'm going to take a look at is this set brightness. This is similar to how the set brightness worked before. It's taking whatever the volume level is, which is this number that we've just created or mathed our way from the accelerometer into a nice 0 to 15 value. So when I set brightness now, I'm taking whatever the volume level is, and I'm remapping it from 0 to the number of steps as its range to 0 to the maximum brightness. So this is taking any number from 0 to 15 and remapping it from 0 to 35. And that's because I wanted that maximum brightness to be 35. We could use the raw numbers, 0 to 15, but I wanted it to get brighter. So I also noticed it was at probably a brightness of 1 and 2. It doesn't show up at all. It's just not enough current, I think, to power the Neopixels. So by broadening this, the steps are bigger. The actual remapping steps are bigger. Let's see. So next thing I'm doing is a little bit of a pause here, which again, I can't remember what problem I was running into, but sometimes if you see these little pauses in here, it's just that the code was running faster than the USB key sends could deal with, or the brightness change commands could deal with, and you'll see problems, or it might not work. And so I solved these just with some little pauses, which is not elegant, but it works. So there they are. The next thing we're going to do is, this is the kind of critical part for linking up the orientation with the number of key presses. So what we do is, remember initially when I start this up and hit the button, we set the volume down to 0, and I even set a variable called key presses, and that's set to 0. So right at that moment when we've pressed the button, it allows those two to line up. The actual volume is at 0, the number of key presses is at 0. So now what we do is we check and see, are those out of alignment with each other? If I start it up and have it pointed straight down, then they're gonna stay they're both 0. So the number of key presses starts out as 0 and my volume level is at 0. So that means nothing will happen, which is good because it means that they're in agreement and they don't have to do anything. So when we start moving the knob around, what's gonna happen is key presses is gonna stay at 0. There's nothing telling it to change. But the volume level will go up. So let's say we bring the volume level up to 5. What's going to happen now is these blocks are going to check and they're going to say, hey, key presses, is it less than 5? Is 0 less than 5? Or is 0 greater than 5? Well, it's less than 5. So we're going to run all the code that lives inside of here. And in fact, we're going to keep running that until the numbers are in agreement. So keyboard media volume up press, so that means we're at 0 on the number of key presses. The volume level is meant to be at 5. In other words, that's where we've rotated it to. So we're going to press that button and we're going to increment the number of key presses variable by 1. So now volume level equals 5, key presses equals 1. And then we're going to do it again, 2, 3, 4, 5. So it's going to do it until those have no difference between them. And it works the same in the opposite direction. So if we get the volume up to, let's say, the maximum, we're at 15, and then we start to rotate, well, rotation causes that volume level, which you can think of as kind of the desired volume level, where we're pointed. So we're pointed at, let's say, down at 4. But the number of key presses variable is sitting up here at 15. So we're going to drop by 1, and we're going to press that button until we are in agreement again, and now they're both sitting at 4. And so the way we do that is, again, we press the button, but in this case it's the volume down button instead of the volume up button. We change the key presses by -1, so it removes 1 from it. And then there's that little pause in there to keep the program from running too fast. So I think it's time for a demo, an actual demo. So I'm glad you could see the volume change icon showing up on my computer. But let's take a look at it on my iPad where we can also hear it a little more easily. So what I'm going to do is I will switch over to this view. And we can move some of this stuff out of the way. And now what I'm going to do is I'm going to unplug my Circuit Playground Express from my computer, so you'll see the power goes off on it. It's powered over USB. And I'm going to now take that USB cable and I'm going to plug it into my iPad. I'm going to need to use this little thing, which is the USB to Lightning adapter. Apple calls these the camera connection kit, I think, still, because they're being stubborn about the fact that people want to use lots of different kinds of USB devices with their iPads. They pretend it's only for camera transfers, I think. So I'll plug that into the iPad, and sometimes you'll see the iPad will tell you that the device isn't there. It said briefly the device isn't allowed on this iPad, then it gave up and decided, okay, I'm fine. So I'm going to... When I press this button, what you should see is the volume will go down. Okay, so it set ringer volume to 0. I'll play a song, and since a song is playing, the iPad will now change the actual volume of the device. So this, as it turns out, is actually a really convenient volume knob. I was using this last night, and it's kind of nice compared to hitting the buttons on your keyboard. So you can mute it quickly by turning that. You can turn it up and down. Now, I mentioned that I had some extra customizations and features that we can do. And one of them, you don't see it in the code there, but I have it running on this one, is I decided I wanted to use the B button as a pause play button. So let's look back at our circuit, or our MakeCode session. Let me go full view on that. And I'll show you how easy it is to add in a new function. So what we'll do is, first of all, I'm going to format my code to bring it all close. Actually, let me collapse it first and then format it. I love this feature so much. And so what I want to do now is I want to say, if I press the B button, then let's send the pause play command. So the nice thing is that the multimedia commands of the HID keyboard standards just consider pause play to be one command that is a toggle. So on the operating system side and on the application programming interface for the different software you're running, such as you're playing a QuickTime movie or listening to something on Spotify or whatever it is, they all just know to toggle their state. So if it's already playing and you send this command, it pauses. If it's already paused and you send this command, it plays. Which is great, because that means that we don't have that problem we had before with the actual relative versus absolute volume of sort of calibrating ourselves or getting to a known state. We don't need it. So this is easy by comparison. So what I'll do is I'm going to go over to the input category. I'll bring in another on button A click. Somewhat confusingly, we already have one, but that's how you get this guy and drop down to all of your input choices on the Circuit Playground Express and MakeCode. So I'll go to button B, and when button B gets clicked, I will run the keyboard. I'm going over the keyboard category, media, mute, press. Let's grab that. And then we're going to pick a different drop down. So some of this you just have to know, or you got to poke around. You got to say, okay, keyboard media, I want pause play, but the only thing that looks even close says mute. Let's grab it, bring it in here, and then look through the choices. So the choice here I want is called pause play. And we could do maybe set all of the LEDs a different color or something like that. But I'm trying to remember. I already have that running. I have this variation running on my machine. In fact, you know what I'll do? I'm going to open a different version of this MakeCode script. This is the much fancier one. And let's look. Let me collapse and format and open the B click. Oh, I just did pause play, so nothing fancy. So let's go to the webcam and you can see this in action. Get some of this MakeCode out of the way here. So that paused. Let me move my webcam a little bit and you'll see there's a little icon here on Spotify that'll change. And pause again. So we're at full volume, but paused, or we can also mute it or lower it. So that was one change that I made. And then let's take a look at the other fanciness. So I mentioned, I think what we're going to do, let's expand all the blocks and we'll format. So I'll just take a look at the changes here. So couple things. You'll notice I now am writing the little LED that's on the Circuit Playground Express. I'm turning that to on. It's a little red LED. I'm turning it on when I start out the program. The rest of that's the same. When I initially press the A button, instead of putting the code all in here, I've created a function. So I plan on using that same code a few places, so I don't want to duplicate it multiple times. I instead create a function. So if we look at the function, it will look an awful lot like what used to be just in the A button. So it's setting pixels to blue, iterating through the number of volume steps, pressing the down button, setting key presses to 0 and setting ready state to true. However, when I want to go between the different operating systems, I had mentioned I have tried this on Mac and Windows. I think I should change these actually to 15. I think 48 on this one. The addition here I have now is when I flip the little toggle switch. So we didn't use that before, but there's a slide switch. When I flip the toggle switch, what I want to do is, again, set my number of steps to the appropriate value for the operating system. So left, it'll do the 15 steps for the Mac. Right, it'll do the 48 steps for Windows. I'm turning that red light on and off just as an indicator to me. It's in Mac mode or it's in PC mode. And then I'm calling reset again. So we do that full, since we want to get the numbers aligned, instead of 0 to 48, it's 0 to 15. So we run through that reset process again. And then when we look at the main forever loop, nothing really has to change because everything is already based on this volume steps variable, which I'm changing based on which operating system. So I think what I'll do, you can actually see this in action. You should be able to just see it on my volume. Let's see, I'm going to plug this back into my computer. Actually, you'll see it a little better. 1 second. Not a very convenient USB hub. Okay. So when I start this up, let me move this out of the way. You should see. Wait, how did I get that volume? How did I make that work before? I swear you saw you saw my volume knob changing, and now I can't remember what I did. What'd I do? Does it work if we're over this video? Oh, you see it faintly, right? I bet if I, you know what? I'm going to go to a gray background. You might see it better. Stand by. There you go. Okay, so you're seeing the volume knob, and this is, let's see, can I make it so you'll see that and my webcam? Let me move this off to the side. I'm improvising here, so bear with me. Oh, not the webcam. Let's move the display capture. Okay, so you can see these at the same time now. So this is the default mode where, my Mac mode rather, where I've got 16 steps, and that gives me the full volume range there. So what I'm going to do is I'm going to flip this switch here, and this is essentially resetting it, but where the number of steps is now 48 because of Windows being 2 steps per step, and it's a 0 to 100. So now what you'll see is as I turn this, I'm going to reach the maximum really quickly. So I've already sent it the full 15 steps. Now it's sending that same key over and over again, and nothing's happening because I'm on a Mac. But if I run on Windows, this would be sending the proper value. So you can see that that gets out of whack quickly until we change it back to Mac mode, and it runs the reset, and now they're in alignment again. And I think iOS was also 16 or 15 steps, so 0 to 15 seemed to work. All right, so that's enough tearing everything apart. Let me bring my green screen back in on MakeCode. And so there we have it. We have a fully functioning volume knob that works on pretty much any computer or iOS or Android device that has a... actually, I haven't tested it on an Android device yet, but you should, because USB HID keyboard commands are pretty standard. So that is going to wrap it up. That is my MakeCode Live project for you this week. I will share the code right now. So I'm going to just, before we go, I'll go back to, which one is it? Volume knob. Just, nope, not 5. This one. Not this one. That one. There we go. Whew. So what we can do is head to the share button here. I'll publish the project. So you can use that QR code right now. If you click that, it'll take you to the project. I'll also copy this and I'll paste it into the different chats there if you want to check that out. Here it comes, all the chats. One more. I've got it going into Mixer, I've got it going into Discord, and I've got it going into YouTube. So there you go. There's the code for you if you want it. And you can definitely do some of this in the simulator, but it's not going to send the HID commands. It does not send USB commands to itself out of the browser, at least not any way I know of. But you can do things like look at the simulator's version of the graph as you try out different values and map them and so on. We can even switch this over to, now it's going to go 0 to, oh, that's the wrong one. Let's go back real quick. Almost out of time, but here we go. So if we look at the knob 5 version, that's my one that has the Windows code in it. If I turn that on and flip this switch, we should be now 0 to 50 mode. Yep. So that's what that change is doing, essentially. It's just changing the number of steps. All right. Well, that about does it. I think we're out of time. So thank you so much for stopping by to MakeCode Live with me, John Park, and I will see you next time. Thanks so much, and bye-bye.